Hello everyone. We were discussing about IPv4 datagram and different fields in that. So we are finished with the first part. We'll move on to the next part of the first session. So the next topic under this is options. So we have finished datagram format. Then we have seen the fragmentation, how the offset address will be generated. Now we'll move on to the options and security of IPv4 datagram. So in this particular video, we'll be learning about different types of options available as well as the security concern of IPv4 datagram. As we have seen, in case of header of an IPv4 datagram, it is actually made up of two parts. First one is fixed part and the second one is variable part. When it comes to the fixed part, the length of fixed part is 20 bytes, whereas variable part comprises of options that can be the maximum up to 40 bytes. The option fields are used for network testing and debugging. Options are not a required part of IPv4 header, but option processing is required. That is, whatever the option fields will be entered, so all the data in that field need to be processed. So when it comes to options, there are basically two types, as you can see in this slide. So one is called as single byte options, second one is multi byte option. Let us see what is this single byte option and multiple byte option. As the name suggests, single byte option is a 1. The size of this is 1 byte. As you can see here, in case of single byte option, it is further divided into two types. One is called as no operation, second one is end of option. So no operation is a 1. It is an option and this is of 1 byte option and used as filler between the options. So whenever you want to use as a filler, then the no operation option will be used. The second one is end of option. As I said, even this is 1 byte option. This is used for padding at the end of the option field. So at the end of the option field, this will be used for padding. So in case of single byte option, we have two types. One is no operation, second one is end of option. So no operation just for filling purpose, whereas the end of option is used for padding purpose. The second type under options, we have multiple byte option. As you can see, there are four different types of multiple byte options available. One is record route, second one strict source route, third one loose source route, and the final one time stamp. So the first one is record route. So this is an option used to record the internet routes that handles the datagram. So I repeat, record route option is a one which is used to record the internet routers that handle the datagram. So which are all the routers which handles a particular datagram, that record will be available or made available through this record route option. So it can list up to 9 router addresses. So it can make a note of 9 router addresses, and it is used for debugging and management purpose. So if you want to record any address of the router the packet is moving, so that can be done using an optional field using a record route option. Next one we have strict source route. So strict source route option is used by the source, that is the sender, to determine or to predetermine a route for the datagram as it travels through the internet. So to determine the route of a datagram, so the strict source route options can be used. Third one, loose source route. This is an option which is similar to strict source route. Each router in the list must be visited, but datagram can visit other routers as well. So this is as similar to the strict source route. So it will have a predefined data of the router that packet will move, but while transmitting the datagram can visit other routers as well. And the last one is timestamp. A timestamp option is used to record the time of datagram processing by a router, that is how much time is taken by the router to process a particular datagram is recorded by making use of timestamp. So these are the 6 different types of options field possible in IPv4 datagram. So each have a specific task to be done. So depending upon the requirement, this will either the single byte, that is no operation or end of operation, or the multiple byte option, that is either the record route, strict source route, or loose source route, or the timestamp option can be used. And the last topic under IPv4 datagram is the security of IPv4 datagram. So as we know, whenever we communicate, the main concern with all the networks is the security. So initially the IPv4 protocol was designed, as well as the internet uses trusted each other, that is the communication used to take place with a trust. So there were no hackers, no third person who used to track the data. So no security was provided for IPv4 protocol. So there was no security was provided when the data was transmitted. But for the today's situation, internet is not secure. So you know, you might be heard many people, many hackers try to get the information while transmitting. So people try to get the information when the data moves through the transmission media. So the three main concern, or the three security issues that is particularly applicable to IP protocol are: one is packet sniffing, second one is packet modification, and the third one is IP spoofing. So these three are the main concern, or the three main security issues related to IP protocol. So we'll see what is this packet sniffing, what is this packet modification, as well as IP spoofing, and how these three issues can be addressed, and what is the solution to overcome this security issues. The first one is packet sniffing. So, as we know, in case of attack, there are two types. One is called as passive attack, one more is active attack. So, passive attack is the one wherein the intruder or the attacker will not come into picture. So, the data will be hacked without knowing, or unknowingly he will take the data. So the sender or the receiver will not come to know that somebody has taken the data. So the packet sniffing comes under this particular category. Packet sniffing is a passive attack in which the attacker does not change the content of the packet, instead intercept the IP packet and make a copy of it. So, as I said, it's a passive attack wherein attacker is not going to change whatever the content is there in the packet. Instead, he'll intercept the IP packet and he'll make a copy of the packet. So original packet will be as it is, it will be sent from source to the destination, but the attacker will create an extra copy of the same. The problem with this kind of security issue is that it is very difficult to detect the attacker. The reason is that sender or the receiver may not come to know that packet has been copied. So because whatever the data, original data has been sent, that will be as it is. So however, packet sniffing cannot be stopped. However, encryption of the packet can be made so that attackers effect can be made useless. So since we are not able to identify whether the packet has been copied or not, so the better way to avoid this kind of security issue is encrypting the data, so that when the data packet is encrypted, only the source or the receiver will able to decrypt the packet back. So if any intruder or any attacker read the data or make a copy of the data and try to read the data without having the decryption algorithm, he can't do anything. So the better way to overcome this kind of issue is encrypt the data while sending, and at the receiver decrypt the data and get back the original data. Second type of security issue is packet modification. So in this method, unless packet sniffing, here the attacker intercept the packet, make the changes in the content and send the new packet to the receiver. So he is going to take the data, he'll create a new packet, or he is going to make the changes and send the data to the destination. So what happens, the receiver will not come to know that the data has been taken or changed by the attacker. So he assumes that the packet has come from the original sender only. So he assumes that it has been come from the same person who has sent it. So there is a change or the modification in the packet. So to overcome this kind of problems, so it can be avoided using a data integrity mechanism. Using data integrity method, these kind of attacks can be avoided. Or when this kind of attacks happens, the receiver will come to know that something has happened to the packet. So using data integrity method, we can avoid the, or we can identify this kind of problems. Third one is IP spoofing. In this method, an attacker can masquerade as somebody else and create an IP packet that carries the source address of another computer. An attacker can send an IP packet to a bank pretending that it is coming from the one of the customer. So something like, instead of sending from data from the sender, one more person act or he behave as if he is the sender, and he is going to create a packet and he is going to send the to the destination, so that the receiver will assume that the original data has come, or the data come from the original source. So these kind of attacks can be prevented using original authentication mechanism. So using authentication mechanism, this kind of IP spoofing can be avoided. So these are the three different attacks which is possible in IPv4 protocol. To overcome this security issues, there is a special protocol which is called as IPsec, or stands for IP Security Protocol, which is used in conjunction with IP protocol, that creates a connection oriented service between the two entities, in which they can exchange IP packets without worrying about the third attacks discussed below. That is, one is packet sniffing, one more is packet modification, third one is IP spoofing. So these three can be avoided using a method called, or using a protocol called IPsec. So IP packets can be protected from the attackers using a protocol which is called as IPsec, in which protocol is used, that is IPsec protocol is used along with the normal IP protocol, that is IPsec protocol is used along with the normal IP protocol, and it creates a connection oriented service between the source as well as the destination, so that they can transmit or they can exchange the information between them without any attack or worrying about the attack. There are four different services provided by IPsec protocol. Is first one is defining the algorithm and the key. Second one is packet encryption. Third one is data integrity, and the fourth one is origin authentication. The first one is defining the algorithm and key. That is, the IPsec protocol will define an algorithm, how actually the connection has to be established, and which are all the key, like public key or the private key has to be used for data exchange. So data communication can takes place based on the algorithm specified and the using the key specified. Second one is packet encryption. That is, whatever the data is generated, or the whatever the packet is ready for transmission, that packet has to be encrypted. So using some method or some algorithm, the packet has to be encrypted, and the encryption algorithm should be known only to the receiver. So once the packet is encrypted and sent to the receiver has to perform the decryption operation, and he has to take back the data. So if you have multiple level of encryption, it is better or more safe. Next one is data integrity. Integrity is nothing but it's a maintenance and the assurance of a accuracy and consistency of a data over the entire period of transmission, and it is one of the uh, crucial aspects while designing and implementation of usage of any system which stores, processes, and retrieve the data. So system will be designed such that, or it will be seen to it that the data communication accuracy as well as the consistency will be maintained, that is without losing any data the packet will be made sure that it will reach the destination. And the last one is origin authentication. So this is nothing but in a information security system, message authentication or data authentication is a property that a message has not been modified while in the transmission, and that the receiving party can verify the source of the message. So the receiver can verify whether it has origin or the data has been sent by the same person from where he is to get. So these are the four services provided by IPsec protocol. So with this we have come to end of the first part under network layer protocol. We have finished the datagram format. We have seen the datagram format, the fragmentation, options, as well as the security of IPv4 datagram. In coming up videos, we'll learn about ICMP protocol as well as mobile IP protocol. Before I end up today's session, I like to give two assignment question. The first question is explain internet protocol IPv4 protocol with a neat diagram. I repeat, question number 1 is explain IPv4 datagram format with a neat diagram. That is the first question. Second question is explain or write a note on security of IPv4 datagram. So, two questions. The first question, as I said, it is very important question. So the datagram format of an IPv4. So you need to draw the diagram of a IPv4 datagram, clearly specifying each field with the size, that is number of bits, as well as explanation for each of this field. So assume that the question has been asked for 8 marks and explain for that particular question. Second one, as I said, it is a security issue of an IPv4 datagram. So as I explained in this video, so you need to explain about packet sniffing, packet modification, IP spoofing, and at the end you need to explain about IPsec. So these are the two questions I'll be giving you as an assignment. Thank you.